I have a Google Cloud server. Let's make a DNS server. So here we go. We have to update it, sudo apt update. So I'm going to make these windows side by side. There we go. Here's my instructions. And there's my cloud server. All right. So I do sudo apt update. What this does is it downloads the list of current versions of everything to put it in my index. If you try to install software, you should always do an update first, or you might be trying to install an old version that is no longer present in the repositories. So it's just a good habit to always do an update before you do any kind of install. So now it's going to install bind9 and some DNS utilities that are used to control bind9. Bind9 is the most famous DNS server in the world. Bind, the standard one, the original one, bind on Linux. And it will install it, and it will start it running automatically. And you can tell, so if I do sudo ss -plun, it'll show me my UDP listening ports. And you can see I'm listening on 53. Named, which is the name daemon, is listening on port 53. And I see some connections here, and I should see a listening somewhere. Kind of trying to get it wider so it doesn't sprawl out so much. See if I can get it to fit. That's the thing about SS, it's kind of big. I do see 53, Yukon. I sort of expected to see the word listening, but maybe I won't see it with that particular utility. Let's try netstat -an. Yeah, and then pipe grep. There we are. That shows me listening ports. And here they are. There we are. Now you can see I'm listening on port 53 on TCP and also listening on UDP, but I think I need to put a switch to see that in my netstat. And so let me see here in the project. See the named process listening on 53. Okay, just not too obvious it's listening here. I guess this Yukon must mean listening. I'm not aware of that term. I'm more used to seeing listen in the other product. Anyway, so now we have a resolver. That means we can resolve by going to 127.0.0.1. So let me get things fitting on the screen better. Okay, there. All right, and clear. So since I'm listening locally, I can dig at 127.0.0.1, and I can look for something, just anything on the internet, like ccsf.edu, and by default, it's a recursive resolver. So it did go find it. It found the right address for City College, even though, of course, my brand new server doesn't have any data about City College or anything else for that matter. It just finds the root, just like the one you made on Windows. It starts with root hints, and it uses them to find the root servers, and it figures everything out by asking externally for it. All right, so now there's a flag you can find just to show that your thing is working here. And then let's view the server cache. Now that I've done a resolution of City College, it should have something in the cache. So I can do this rndc command. This is one of the DNS utilities. And dumpdb will put a copy of the cache somewhere where I can access it. And this should open it in an editor. And there it is. Here's the data in the cache. Let me just, oh, there we go, good. So the only thing I went to, I think, was CCSF, so I should be able to do Control W and look for CCSF. Control W is search in Nano. And there you are. Here's some CCSF information in the cache. So I did look up CCSF, so now my local resolver has cached it, and it will keep it for a very long time, 172,000 seconds. I don't know why it's so big, but anyway, it now has a cache of this data, and that's what you'd expect. So it's a caching resolver by default. All right. And if you did the project, you'll have samsclass.info also, because that was probably you got the flag by doing a query to samsclass.info. And now we can view DNS delegation. This command will dig for ccsf.edu using trace, so it won't use the cache. It'll do the full process of figuring it out. And this grep will just show me only the lines that have from, so it's easier to read, so I don't have a whole page of data from each one of those queries. So there you go. It will show me just one line for each query it sent off. And there we go. So it went to the local resolver, 127.0.0.1, and then it went off to the root servers for .NET, and then it went to EDU servers to find the root of EDU, and then it went to Scenic, which is the server that can tell about CCSF. Scenic is our internet service provider. So you can see this just shows you the 4 steps of finding that information. All right, and then there's another flag to find here, so that's it. Once you have a Linux server going, it's pretty easy to do everything on Linux, much simpler than doing it on Windows, it usually is. Anyway, that's all I wanted to show you about that one. I'll stop this recording.